Whether you're a tech enthusiast, industry professional, or just curious about the future of AI Agents Unleashed will keep you informed and inspired. Buckle up and get ready to unleash the potential of AI.
Hey there, welcome to your personalized deep dive. Today, we're going to be looking at something called self-invoking code generation.
Ooh, that's it.
It does sound very technical, but
Cocktail.
it's really a fascinating topic.
It is.
And it gives us like a glimpse into the future of AI and coding.
Yeah, for sure. We're really talking about LLMs,
Okay.
large language models,
Yeah.
and their ability to not just like write code, but to really use that code like building blocks to solve bigger problems.
So it's not just like spitting out lines of code.
Right.
It's understanding how those lines can fit together
Exactly.
to make something
Exactly.
much bigger and more intricate.
Yeah. And to test this, researchers have created these new benchmarks
Okay.
called HumanEval Pro and MBPP Pro.
Interesting.
So they're basically like coding exams for LLMs, but with a twist.
Okay, what's the twist?
So imagine you're taking a test and the first question
Right.
gives you a clue for solving the second one. That's what these benchmarks are like. Okay.
So the AI has to first solve a basic coding problem and then use that solution to tackle a related but more complex problem
Got it.
that builds upon it.
That makes sense.
So it's self-invoking.
Okay, I see why that would be really, really challenging.
Yeah.
Are they passing with flying colors?
Not quite.
Okay,
That's where it gets really interesting.
all right.
A lot of LLMs are really good at writing code for simple tasks, but when you give them these self-invoking tests, they kind of hit a wall.
Really?
Yeah.
I thought these LLMs were like,
You'd think, right?
coding superstars.
Yeah.
What's tripping them up?
It seems like integrating code into larger, more complex solutions is a whole different ballgame. Think of it like knowing the moves in chess versus actually strategizing an entire game.
Right.
It's a whole other level of complexity.
It's like knowing how to do a bunch of dance moves versus actually choreographing.
Right, exactly.
Yeah.
And that's where they seem to be struggling. So even if an LLM knows how to write code for, like, let's say sorting a list of numbers,
Right.
it might not know how to use that code as part of a larger program that maybe organizes data in a specific way or something like that.
It's like they can write the sentence, but they can't write the novel.
Oh, that's a good way to put it, yeah.
And that's what's so interesting about this research.
Yeah.
It shows us where these LLMs need to get better.
So what are we seeing in the results of these benchmark tests?
Well, even the top LLMs are showing a pretty dramatic drop in accuracy when you give them these self-invoking tasks.
Okay.
Like, for example, O1 Mini, which is a top performer when it comes to reasoning.
Right.
It scores 96.2% on HumanEval.
Wow, that's really good.
Yeah, but on HumanEval Pro, it drops to 76.2%.
Oh, wow. That's
Big difference.
a big difference.
Yeah.
Self-invocation is a real hurdle.
It is.
But why? What's causing those errors?
Well, the study looked at the specific errors.
Huh?
Most of the time, the code doesn't pass the test. And that results in what's called an assertion error.
Okay.
And other times, the code uses variables that haven't been defined.
Right.
And that causes a name error.
So it's like they get the general idea,
Yeah, it's like
but they mess up the detail?
the execution isn't quite there.
Yeah.
It's like they understand what they're supposed to do,
Uh-huh.
but they can't quite translate that into a working solution.
This is so fascinating.
Yeah.
The self-invoking code generation is really,
It is.
it's a big deal.
It is. It's pushing the boundaries.
What about those instruction-tuned models?
Oh, yeah.
The ones that get, all that extra training and data?
Right.
Shouldn't they be better at this?
You would think so, right?
Yeah.
But actually, the research shows that instruction-tuned models don't necessarily have a big advantage when it comes to these self-invoking tasks.
Wait, so all that extra training doesn't always mean better performance
Not necessarily.
on these more complex problems?
Yeah. It's a bit of a head-scratcher.
That's counterintuitive.
It is?
Why would a model with less training
Right.
outperform
Yeah, why was the...
fine-tuned one?
Yeah, why would the student do better than the master?
Yeah.
That's something that researchers are still trying to figure out. There's something about self-invocation
Right.
that even throws these very sophisticated LLMs off balance.
Makes you think.
It does.
Okay, so we've got these benchmarks. HumanEval Pro.
Right.
MBPP Pro,
Yeah.
highlighting this challenge of self-invocation. But you also mentioned Big Code Benchlight Pro.
Yes.
How does that fit into all of this?
So that one expands beyond just Python,
Okay.
which is what HumanEval Pro and MBPP Pro focus on.
Right.
It actually pulls from lots of different coding problems
Oh, wow.
across different domains.
So instead of just being like a Python expert,
Right.
the AI has to be like a coding polyglot.
Exactly. It has to be able to speak all the languages.
Yeah.
And the cool thing is the results are pretty consistent.
Okay.
Even with all these different problems,
Mm.
LLMs struggle to get above 50% accuracy.
With self-invoking code generation.
Exactly.
So it's really a consistent stumbling block.
It is.
Is there hope?
Oh, absolutely.
But
Like, remember we talked about chain of thought prompting?
Right, like where we kind of guide the LLM to think step by step.
Exactly. Giving them a little nudge
Yeah.
to break down the problem.
Yeah.
Well, that's a really promising way to make them better at these tasks.
Interesting.
It's like giving them better thinking tools.
So prompting them to think things through could be a key
It could be, yeah.
to unlocking their full potential in this area.
Potentially.
Okay, and beyond that, what else is there?
Well, remember those errors we talked about?
The assertion errors and the name errors.
Exactly.
Yeah.
Well, those are actually super valuable
Mm-hmm.
because by studying them,
Mm-hmm.
researchers can figure out why LLMs struggle
Right.
with self-invocation.
Right.
So it can help them come up with new training techniques.
So it's not just about getting them to write code.
Right.
It's about getting them to write
Robust, reliable code.
good code.
Yeah,
That really understands the task at hand.
that's the key.
Yeah, this is all incredibly insightful.
It is. It's a fascinating area.
We're really like pushing the boundaries of what these LLMs can do.
Yeah, we are.
It's exciting.
It is. It really is.
Now, before we move on, I want to bring this back to our listener for a second.
Okay.
What are some key takeaways that you think they should really ponder on?
I think the biggest takeaway is that even though AI has come a long way,
Yeah.
there are still some pretty big challenges.
Uh-huh.
And self-invoking code generation really highlights that.
Yeah, it really shows us where the limitations are.
Exactly.
It's a reminder that these LLMs are tools.
They are tools.
Right.
They're not magic.
And they have limitations.
They do.
Just like any other tool.
Yeah, and it's up to us to understand those limitations
Right.
and work towards making them better.
To develop AI systems that can do even more,
Exactly.
really push those boundaries.
Push those boundaries.
Well said. This has been a really great conversation so far.
That has.
Really insightful exploration of this whole world of AI and coding.
Yeah.
I believe that as these LLMs continue to evolve,
Right.
these benchmarks,
Yeah, they're going to be
HumanEval Pro, MBPP Pro, Big Code Benchlight Pro,
Yeah.
are going to be crucial for guiding their development
Uh-huh.
and pushing their limits even further.
They're going to show us what they can do.
It's a continuous process
It is.
of challenge and improvement,
Exactly.
pushing them to be more and more sophisticated.
Yeah, pushing those boundaries.
That's a perfect note to end on.
It is.
But before we wrap up, I want to hear your thoughts on something.
Okay.
If we can train AI to write code that calls upon itself,
Right.
could we also teach it to analyze
Mm-hmm.
and improve
That's a good question.
existing code using the same principles?
That is a fascinating thought.
Yeah.
Imagine like an AI that can debug and optimize.
All the code that already exists.
Yeah, all those millions of lines of code.
It's mind-boggling.
It is. It really is.
But I think that's a deep dive for another day.
I think so.
Yeah,
It's a lot to unpack.
it is.
But it does seem like the possibilities are endless.
Yeah, as vast as the code itself.
Exactly.
Well, until next time,
Yes.
keep exploring and stay curious.
Absolutely. It's fascinating, isn't it? All this training
It really is.
doesn't necessarily mean better performance.
So it's not a guarantee.
And not when it comes to these more complex problems anyway.
No, it seems like it's not. That's really counterintuitive.
It is. It is.
Why would a model with less training
Yeah.
sometimes outperform a more fine-tuned one?
Yeah, it's almost like
Yeah.
the student doing better than the master.
Yeah, like how is that possible?
And that's something researchers are still trying to figure out.
Yeah.
It's really a mystery.
Okay, so we've got these benchmarks. We've got HumanEval Pro, we've got MBPP Pro, highlighting this challenge of self-invocation.
Right.
But you also mentioned earlier Big Code Benchlight Pro.
Yes.
How does that fit into all of this?
So that one actually goes beyond just Python,
Okay.
which is what HumanEval Pro and MBPP Pro focus on.
Yeah.
It pulls in a whole bunch of different coding problems from all sorts of different domains.
Wow. So it's like,
Like
instead of just being a Python expert,
yeah.
the AI needs to be a coding polyglot.
Exactly. It has to be able to speak all the languages.
Wow.
And the really interesting thing is
Yeah.
the results are pretty consistent
Okay.
with what we see on those other benchmarks, even with all these different problems.
Yeah.
A lot of these LLMs are struggling to get above 50% accuracy
Really?
when it comes to this self-invoking code generation.
Okay, so the self-invoking aspect
Yeah,
really is a major stumbling block.
it is a big hurdle.
Is there hope for these LLMs?
Oh, absolutely.
Okay.
To become,
Yeah.
masters of this self-invoking code. Yeah. I mean, remember we talked about that chain of thought prompting?
Right, where we're kind of nudging the LLM
Right, giving them a little bit of guidance.
to think step by step.
Yeah, help them break the problem down.
Well, that seems really promising.
It is. It's showing a lot of potential.
Interesting. So prompting them to think things through could be a key
It could be a key, yeah.
to really unlocking their full potential
It's one way to help them get over that hurdle.
in this area.
Exactly.
So beyond chain of thought prompting,
yeah.
what else is there?
Well, remember those errors we talked about?
Yeah, the assertion errors,
Yeah.
the name errors.
Exactly.
Those were really interesting.
They are.
Because it seems like by studying those errors,
Right.
researchers can get a better understanding of why
Yeah, like what's going on under the hood.
LLMs struggle with this self-invocation.
Exactly, where they're tripping up.
Yeah, and maybe even come up with new training techniques.
Yeah, new approaches.
So it's not just about getting the LLMs to write code. Right. It's about getting them to write
Good code.
good, robust,
Right.
viable code
Yeah.
that really understands the task at hand.
That's the goal, right?
Yeah.
To get them to really understand what they're doing.
This is all so insightful.
It is. It really is.
It feels like we're on the cusp of something
I think so, too.
really revolutionary with this self-invoking code generation.
It has so much potential
Yeah.
to change how we write code.
Yeah. So before we go too far down that road,
Okay.
let's bring this back to our listener for a second.
All right.
What are some key takeaways
Okay.
that you think they should really ponder on?
I think the biggest takeaway here is that even though AI has made incredible progress,
Yeah.
there are still some really fundamental challenges to overcome.
Yeah.
And self-invoking code generation really highlights those challenges.
It does. It really shows us where those limitations are.
Exactly. And it's a reminder that these LLMs are tools.
Right.
They're powerful tools.
Yeah.
But they're still just tools.
And like any tool, they have limitations.
Exactly.
Yeah.
It's up to us to understand those limitations.
Yeah, right.
And to work towards overcoming them.
Yeah, to really develop AI systems that can do even more.
To push those boundaries even further.
Well said. This has been a really fantastic conversation.
It has been. It really has.
Really insightful exploration of this whole world of AI and coding.
Yeah, it's a fascinating field.
And I believe that as these LLMs continue to evolve, these benchmarks like HumanEval Pro,
They're going to be crucial.
MBPP Pro, Big Code Benchlight Pro,
Yeah, they're going to be so important.
they're going to be crucial for guiding their development
For showing us where they need to improve.
and pushing their limits even further.
Exactly. It's all about pushing those boundaries.
So it's a continuous process
It is.
of challenge and improvement,
Always pushing forward.
pushing these LLMs to become more sophisticated
Yeah,
and even more capable.
that's the goal.
That's a great note to end on.
It is.
But before we wrap things up,
Yeah.
I want to hear your thoughts on something.
Okay.
If we can train AI to write code that calls upon itself,
Right.
could we also teach it to analyze and maybe even improve
That's an interesting thought.
existing code?
Yeah, like what if AI could
Mhm.
not just write new code,
Yeah.
but actually debug and optimize all the code that already exists?
All the millions and millions of lines of code out there.
Yeah, the possibilities are pretty mind-boggling.
Yeah, that is a really fascinating thought.
It is.
But I think that's a deep dive for another day.
Definitely a topic for another deep dive.
It is, yeah.
We could spend hours talking about that.
All right, well, until next time,
Yes.
keep exploring and stay curious.
Absolutely. Those
Cool.
error types, the assertion errors and the name errors, I'd love to unpack those a bit more.
Yeah, for sure. They really give us some insight into how those LLMs are thinking and where they might be struggling.
Yeah. Can we start with the assertion errors? Yeah. So basically, an assertion error means that the code didn't produce the expected output. So it might look right, but when you actually run it, it doesn't work the way it's supposed to.
So it's not a complete failure,
Right.
but it's not really a success either.
No, it's like following a recipe perfectly,
Right.
but your cake comes out raw in the middle.
Yeah, it's like you did all the steps,
You did all the steps,
but the outcome
but it's not edible.
wasn't quite there.
Exactly.
It seems like that points to a problem with how these LLMs translate their understanding into a real solution.
Yeah, it's like they can understand the individual steps,
Right.
but they can't quite put them together into a whole that works.
Yeah, and that's a big challenge for self-invoking code, right?
Absolutely.
Because you need all those pieces to fit together.
It all has to work together seamlessly.
Okay, now what about those name errors?
So a name error means that the LLM used a variable or a function that hasn't been defined anywhere in the code.
So it's like trying to follow a recipe,
Yeah.
and it calls for some mystery ingredient.
Right, some secret ingredient that nobody knows about.
But it never tells you what it is or how to get it.
Exactly. It's like they're missing a crucial piece of information.
It's a breakdown in communication.
It is. It's like they have all these ingredients in the kitchen, but they don't know how to combine them to make a meal.
Yeah. This has been a really fascinating deep dive.
It has been.
I feel like we've really gone deep into this world
I think so.
of AI and coding.
We've really explored some uncharted territory.
So to kind of wrap things up here,
Yeah.
what does all of this mean for the future of AI-powered coding?
Well, I think those errors
Yeah.
are actually opportunities
Mm-hmm.
because by understanding where LLMs stumble, we can make them better.
So we can improve our training methods
Exactly.
and come up with new techniques
New approaches
and ultimately create AI systems that are even more capable.
and more reliable.
It's like we're watching their evolution in real time.
Yeah, it's like we're seeing them learn and grow.
And every mistake brings us closer to unlocking their true potential.
I think that's a great way to put it.
So as we develop these LLMs that can not only generate code,
Right.
but reason about it, analyze it,
Even improve it.
improve it, it really does open up a world of possibilities.
It does. It really
It's
does.
like AI collaborating with human developers,
Working together
automating tasks, finding bugs.
and helping us write better code.
It sounds like something out of a sci-fi novel,
It does, doesn't it?
but it's happening right now.
It is. We're living in the future.
This has been an absolutely enlightening conversation.
I've really enjoyed it.
Any final words of wisdom for our listener before we sign off?
I would just say, never stop being curious, because it's curiosity that drives us to explore and to learn.
It pushes us beyond our limits.
Exactly, and I have no doubt that curiosity will continue to lead us to incredible breakthroughs.
Well said. Thank you so much for joining us on this journey
It's been a pleasure.
into the world of self-invoking code generation.
A fascinating world indeed.
Until next time, keep exploring and stay curious.
Absolutely, and keep coding.